Welcome to this explainer where we're uncovering the thrilling, almost espionage-like world of weeds. You know, nature's most highly adapted master infiltrators. We literally walk past them every single day, yanking them from our gardens, ignoring them on the sidewalk. But right beneath the surface, these plants are actively staging one of the most complex, relentless survival campaigns on planet Earth.
All right, let's just dive right in with what might be the ultimate revelation here. Biologically speaking, weeds don't actually exist. Crazy, right? There is absolutely no botanical family tree for a weed. The whole thing is just a human construct. Agriculturist Jethro Tull famously nailed this way back in 1731, defining them simply as plants which grow where they are not wanted. Basically, they're just a plant out of place. A beautiful wild grass instantly becomes a weed the exact second it crosses the border into your manicured lawn.
But look, just because the concept is man-made doesn't mean the problem isn't very, very real. Out of the 30,000 weed species we've identified worldwide, a staggering 18,000 of them are actively causing damage to our crops and ecosystems. Think about that for a second. That is an enormous army of opportunistic plants perfectly evolved to absolutely thrive wherever we disturb the soil.
And when you look at their rap sheet, weeds are easily public enemy number one. Take India, for example. Weeds are responsible for a massive 45% of total annual agricultural losses from pests. I mean, they are completely outpacing the damage done by insects, which sit at 30%, and diseases at 20%. They are basically the silent green thieves of the agricultural world.
These infiltration tactics steal vital water, soil nutrients, and physical space, leading to some seriously devastating yield reductions. Just to put that into perspective, look at the impact on onions. You can see an incredible 90.7% reduction in harvest if weeds are left unchecked. Over 90%. And it's not just onions. Sugar beets, cotton, and sugarcane are all losing massive chunks of their yield to these aggressive competitors.
Plus, these botanical villains aren't just stealing resources, they can be downright hazardous to our health and our food supply. For instance, weeds like the Mexican poppy contain a highly toxic alkaloid called sanguinarin. If that gets consumed through contaminated animal milk, it can actually cause glaucoma in humans. Then you've got cocklebur seeds, which can make wheat flour taste painfully bitter and severely irritate the gastric tract. And that's not even mentioning the classic everyday miseries, like asthma from weed pollen or contact dermatitis from poison ivy.
But you know, every good villain has to have a sympathetic side, right? Secretly, some of these plants do a bit of charity work. The aquatic weed Eichhornia, for example, acts as a fantastic natural indicator of copper pollution in water bodies. Others bring medicinal properties to the table, like Lucas aspera, which has traditionally been used to treat snake bites. Some, like Amaranthus, even serve as highly nutritious leafy greens. So it's a complicated relationship for sure.
Categorizing the culprits, the modus operandi.
To actually fight these master infiltrators, agronomists first have to understand their clever disguises, starting right with their physical structure. They're broadly split based on leaf morphology. On one side, you have monocots, like grasses, which feature narrow, upright leaves with parallel veins. On the other side, you have dicots, or broad-leafed weeds, with horizontal leaves and a net-like vein structure. Now, why does this matter? Well, this physical trait is absolutely crucial, because it dictates how these plants absorb or repel defensive chemicals, like selective herbicides. As you can imagine, a broad horizontal leaf catches a whole lot more chemical spray than a narrow, upright one.
This understanding of their physical traits really highlights their more aggressive tactics. Take a look at the parasitic weed Striga, commonly known as witchweed. It's wild. It literally latches onto the underground root system of a host crop, like a whole field of maize, and completely hijacks the plant's water and nutrients for its own nourishment. But perhaps their most deceptive disguise of all is something called phenotypic mimicry. This is where weeds evolve to look exactly like the crops they're trying to infiltrate. Jungle rice is a perfect example. It imitates real rice plants morphologically. But it goes further. It even matches the crop's exact life cycle, ripening at the exact same time so its seeds get harvested and replanted right along with the actual crop to completely avoid detection. It's literal botanical camouflage at its finest.
Masters of multiplication, the arsenal.
You see, for many weeds, producing seeds is just plan A. Plan B is where their vast and bizarre reproduction methods get really wild. Instead of just dropping seeds, perennial weeds utilize this incredibly sophisticated underground espionage network of vegetative propagules. They don't even need a mate. They can literally just clone themselves. They send out stems and roots to conquer new territory using specialized structures like rhizomes, runners, and bulbils.
These covert underground structures can take a few different forms. You have the horizontally growing rhizomes, like you see in imporodic grass, and the vertically growing rootstocks of things like sorghum halepensi. What makes these so formidable is that they store massive amounts of energy in buds, ensuring the weed resprouts even if a farmer completely chops down or destroys the surface plant. You might think you've killed it, but nope, it's just waiting patiently underground.
And their aquatic operatives are just as impressive. Weeds like Pistia and Eichhornia, which you probably know better as water lettuce and water hyacinth, utilize structures called offsets. They also develop these swollen, spongy petioles, which are essentially built-in flotation devices. This allows them to rapidly multiply and form massive, dense, floating mats right across lakes and vital irrigation channels.
Now, to travel across the world, these escape artists hitch rides using some incredibly clever adaptations. Some grow these adorable feathery parachutes to catch the wind and just fly for miles. Others develop spiky hooks and spines designed specifically to grab onto passing animal fur or, farmers' clothing. They'll hide in farmyard manure, ride along in contaminated crop seeds, and happily attach themselves to human equipment. They are literally using us as their own personal transit system.
Nature's ultimate escape artists. All of these tactics, the mimicry, the underground networks, the clever hitchhiking, they all culminate in the most mind-blowing aspect of the weed's villain profile: their sheer, undeniable resilience. Their ability to multiply via seeds is just staggering. While a normal plant might produce a few dozen or maybe 100 seeds, a single amaranthus plant can drop an unbelievable 196,000 seeds into the soil. Even Chenopodium drops around 72,000. It's just an overwhelming numbers game that basically ensures at least a few will survive whatever we try to throw at them.
And they are so fiercely determined to pass on their genetics that certain weeds, like the perennial sow thistle, can successfully set completely viable seeds even after they've been totally chopped down. Seriously, if you cut it during its flowering stage and just leave it on the ground, it will literally siphon the last bits of energy from its dying stem to push those seeds to maturity. It's wild. But their ultimate magic trick, the one thing that makes them nearly impossible to truly eradicate, is seed dormancy. They can literally hit pause on their biological clocks. In one truly mind-bending example, lotus seeds found buried in a Manchurian lake bed remain viable and ready to sprout after an astonishing 1,000 years. A millennium. They can quite literally just wait us out.
Knowing they can wait centuries to sprout, mimic our crops perfectly to hide in plain sight, and out-reproduce almost everything else on Earth, well, it really begs the question, are we fighting a losing battle against nature's ultimate survivalists? Because as long as we continue to cultivate the Earth, these master infiltrators will undoubtedly be right there with us, adapting, surviving, and just waiting for their moment to thrive.